It would be very difficult to fly a modern light aircraft safely without its engine instruments. Some engine instruments are what are termed engine condition indicators. These include the oil pressure and oil temperature gauges and the exhaust gas temperature gauge. They literally show the actual condition of the engine. Other engine instruments are called performance indicators. Within this group are placed the engine RPM gauge and the manifold pressure gauge. They are intended to show how well the engine is performing. Furthermore, without engine instruments, effective management of the engine would be impossible. The engine would not give long and efficient service, and faulty operation would be commonplace. It's thus essential that engine instruments be fitted to aircraft and that they function correctly. The pilot must also be assiduous in monitoring the engine instruments. Piston engines are heat engines. The power they produce is directly proportional to the heat released during the combustion of the fuel. Engine components and systems are designed to withstand certain temperatures. If the temperature limits are exceeded, the components may fail. To allow safe operation, the engine temperatures must be monitored. The following temperatures are monitored in piston engines: oil, exhaust gas, and cylinder head. Monitoring the engine oil temperature is important from at least 2 points of view. Firstly, the oil itself will only retain its lubricating properties up to a certain maximum temperature. Above that temperature, the oil breaks down and the moving parts of the engine begin rubbing against each other and getting even hotter. Engine failure quickly follows. Secondly, the engine expends a percentage of its power forcing the oil into the bearings. The colder the oil, the larger that percentage of what is essentially wasted power will be. If the aircraft is to perform safely, the engine oil temperature must reach a certain level before the pilot can be sure that his engine is delivering the power to the propeller that the manufacturers intended. Oil temperature is normally sensed where the oil enters the engine, after it has exited the oil cooler. In a typical engine oil temperature indicating system, the indicator is powered by the aircraft electrical system. An electrical resistant type thermo bulb installed in the engine oil pump housing measures the temperature of the oil entering that unit. The temperature reading is transmitted to the indicator, usually in degrees Celsius. An exhaust gas temperature gauge can show you whether your engine combustion chamber is running too hot or too cold, too lean or too rich. An exhaust gas temperature probe is installed about 4 inches from the cylinder head on the exhaust system. The probe is the junction of 2 dissimilar metals. This is called a thermocouple. When a thermocouple is heated, a voltage is produced which is proportional to the temperature at the junction. The gauge is a millivoltmeter, which is calibrated in degrees Celsius or Fahrenheit. Although the exhaust gas temperature gauge can help in troubleshooting a problem on the engine, it's primarily a fuel management instrument. The cylinder head temperature gauge is an engine instrument designed to protect the engine against its enemy, excessive heat. The principle of operation of the cylinder head temperature gauge system is similar to that of the exhaust gas temperature gauge. A probe is mounted on the engine cylinder head, and this sends a voltage to the gauge in the cockpit, which is proportional to the temperature. Most general aviation engines sample the cylinder head temperature of the hottest cylinder. The hottest cylinder is determined by extensive flight tests carried out by the engine manufacturers. The function of many aircraft engine systems relies on liquids and gases whose pressure must be measured and indicated. The gauges and indicating systems fall into two categories: direct reading and remote indicating. Direct reading describes the type of instrument used when the fluid that is being sampled is fed directly to the interior of the instrument positioned in the cockpit. Remote indicating is where a separate sensing element is connected to a pressure source at some remote point, and the information required is transmitted electrically to the instrument in the cockpit. Pressure is defined as force per unit area. In engine instrument terms, it's normally indicated in either pounds per square inch or inches of mercury. In connection with engine pressure measurement, we are concerned with the following terms: absolute pressure and gauge pressure. Most pressure gauges measure the difference between the absolute pressure and the atmospheric pressure. To actually measure pressure in a system, elastic pressure sensing elements are used in which forces can be produced by applied pressures and converted to mechanical movement. The movement can then operate a direct reading gauge or an electrical transmitter. The sensing elements commonly used are diaphragms, capsules, bellows, and Borden tubes. Diaphragms consist of corrugated circular metal discs which are secured at their edge, and when pressure is applied they are deflected, as shown here. Diaphragms are used to measure relatively low pressures. Capsules are made up of two diaphragms placed together and joined at their edges. The device thus constructed can then be used to either form a sealed chamber, which is called an aneroid capsule, or a chamber which is communicated to a pressure source, which is called a pressure capsule. Capsules, as diaphragms, are also used to measure low pressure, but capsules are more sensitive to small pressure changes than are diaphragms. The bellows-type element can be considered as an extension of the corrugated diaphragm principle. It may be used for high, low, or differential pressure measurement. The Borden tube is about the oldest of the pressure-sensing methods. The element is essentially a length of metal tube which has an elliptical cross-section. The tube is shaped to represent the letter C. One end of the tube is sealed. This is called the free end. The other end is connected to the pressure source and fixed so that it cannot move in relation to the instrument base. When pressure is applied to the tube, it tries to straighten. This movement is magnified by levers and used to drive an indicator pointer. The Borden tube can be manufactured to indicate high or low pressure, but it is normally associated with higher pressures, such as engine oil pressure.